This video it's about refurbishing old Craftsman Jointer. We're gonna fix some issues this jointer has. I don't know which generation of jointer it's this, but definitely it has some problem. I don't know if it's design flaw or what the machine, the casting. This is 6-inch jointer. It's very heavy. It's all cast iron. I think it's going to be a pretty good jointer for doing some work. So I disassembled the angle plate because that one has main problems, and then we're gonna see first what the problems is with this part and how we're going to fix it. Okay, so original assembly was this screw is going slide here, and then it was mounted like that. But the screw is not in the center of that hole. I tried to file this surface a little bit, but it's pretty hard material, difficult to file it. But what they did to compensate for that, they actually put one bushing that is much smaller than the hole, so that they have more space to change the angle. So what I did, you know, when you try to adjust the angle, everything is very flimsy because there is no support on the other side. And this is also cast iron. It is pretty heavy, you know, when you deal with that, especially because there is nothing on the other side. So I decided to machine bushing that is actually fit exactly in that hole. Right now you cannot see it, but if this is mounted here on 3 screws, you cannot put that screw in because this is too long in sitting on a table, and this is all the way up against this surface, you know, and you still cannot put a screw through. There was one option, you know, just to grind the surface of that so that it has a clearance between the table and there, or do something with this part. So I don't know, when they cast, maybe they didn't put that slot on correct position, maybe they didn't put these holes for mounting it or holes on the main table correctly, but basically it doesn't fit, you know. So you put it like that with this mounted, and you cannot put a screw in. But if you put this bushing that was here, that was sloppy, you know, then you can actually lift this more, but then you have a very difficult time adjusting the angle, sliding it back and forth. So I decided, instead of modifying this piece, to modify this piece here. And I didn't like that sheet metal piece that prevents bolt from rotation. I decided to do this a little bit different. This is my idea how to modify this part. You know, machine this surface more to open the hole a little bit more. It doesn't need much, maybe 1/16 of the inch. I will machine that part and also machine this other part, other side, just to make it straight and smooth. Machine this surface around the hole and machine this surface. So then I will make the T-nut that fit in this area without a lot of play. When you mount it, you know you will have a little bit more clearance for the bolt. And then I also not gonna use this bolt and this nut that originally is there. I will use actually this screw with a lever, you know, that you can press the button and rotate, you know, so that you can rotate so that it's not on your way. You can remove it. This is going to go through here, and there will be a nut on the back side. I think the screw is maybe a little bit too long. I'm gonna cut it so that it has enough clearance to go through here. Once when it's all these things done, I'm gonna make the nut, T-nut, but I'm not going to drill and tap this hole. I'm going to adjust, assemble everything, attach this part, you know, to this plate, mount it here, use angle block, you know, to make it vertical, put some shims underneath so it has some clearance between the table and this angle plate. And then I'm gonna use a transfer punch and through this hole punch the hole into the T-nut and then drill it at top. That's how I'm gonna make sure that it's on a correct location and that it has a clearance so that it's operational, you know, properly. This is 8mm screw, so I need to make a new bushing, and probably I'm gonna make it with the flange all around, so when it comes here I don't have to put any washer or anything, because before here there was 3 washers. I don't know, probably has some problem with the screw or thread in here, but anyway, it was something like that. Okay, I'm going to machine these parts using my CNC mill. This is bolt-on M4 CNC machine that I bought. It has a 4-axis. It was pretty bad. I had to do lots of modification to make this machine running like I want to. This part will be much easier to machine on a manual milling machine, but I don't have a manual milling machine, so I have to machine it on a CNC. I'm not going to run it program. I'm going to use my controller, run machine manually with this encoder, because it's going to be much faster than create this part in the CAD and then make NC files to run it. This machine runs with the Mach 3 and it wasn't very accurate, so I installed digital readouts on 3-axis and just to verify how machine works, and then later I replaced the motors and used the closed loop motors. But even this, it's not good because it still has a couple thousand backlash on a y-axis that I don't like. So most likely I'm going to just use the output from the linear encoders and connect to the driver and disconnect encoders from the motors. I could save some money if I just bought the drivers and left the stepper motors in there, but used the linear encoders just for the positioning. But I already found some good package with 3 motors and the 3 drivers. So I replaced them. I built enclosure around the machine because originally there was, making big mess. Things are flying around everywhere. And this is my studio where I do actually mostly electronics. And I bought machine just to making some enclosures and things like that. So I put the enclosure, especially when I run, with the cooling system, there was spraying everywhere. This didn't last a long time. In a very short time, the pump died. So now I'm using the cool misting system, and this works fine. I installed this on this machine and on my lathe. And the tool and the material stays completely cold, when you're machining something. I'm going to first move machine to the position. I know I should not be using vise for that because it has a slot inside. So even this is cast iron, but it's still flexible when you tie it in a vise and compress a little bit. But for this purpose, even accuracy of 10,000, it's great. I just didn't want to remove the vise and put a part and clamp it and index it, and it will take me forever to do that. So I just put it in a vise, and I'm gonna machine it like that. I'm using this controller, adjust the part. I have it on a slow speed, on a 3 inch per minute. So then even this thing is working slow. So I'm using steps of 100,000. So every step on encoder actually move 100,000, but with a speed of 3 inches per minute. So then I can use this like a manual machine. I have planned to modify this machine to make it also operate as a manual machine, because I like working on manual machines. I like working on my lathe, and for some things much better if you don't do profiles and all kind of things like that, 3D machining. The manual machine is just as good as you can get. So I'm probably gonna run it dry because this is cast iron. It's very well lubricated. End mill is this 4-float carbide end mill. It does a pretty good job. So I will put the spindle speed to about 1000 RPM. So in a Mach 3, I'm using the MDI mode for the machining, not in a program. I'm removing only 10,000ths of the inch. And if it's making lots of noise, I will turn on the misting system. Switching again on 100,000 steps, and start moving in a X direction. wasn't enough. So I need to go down another 10,000. Okay, so okay, so we finished this part that was machined, you know, the groove and also inside. So we have the T-nut, it's not yet drilled, it fits here and it's nice and smooth, it doesn't have a play, so it's going to be okay. Also the new bushing with 8mm holes, okay, and this is going to be the locking. I also drill two small 1/8 holes, okay, this one and this one here, so when it's mounted here I will lay the drill through those holes and put some registration pins, so when you assemble that it always goes on the same location, so that angles are going to be accurate, I mean coarse accurate. So later I'm just gonna take those two screws out and just move these things so that show the correct 90 degree. Here we have an angle block that is mounted with the clamps to hold this angle bracket at right angle, and here underneath it's 1/16 some brass sheet metal, so this thing is sitting, so this is gonna create a clearance between this and the table. Okay, so now we're going to assemble those parts. Okay, so use the transfer punch to mark on a T-nut where I'm gonna drill and tap the 8mm holes. Okay, so we're gonna start assembling this. Okay, so later we're gonna drill also a couple holes here and put the pins so that it always go to the same location and it doesn't change center of the rotation. Okay, so I had to clamp the nut from the back side so that I can hit it with a hammer and mark for the drilling. I hope you're gonna be able to see it. Okay, I can see the hole. Now I'm gonna need to drill it and tap. Okay, so this is a finished jointer. I had to do some additional modification that I didn't record it, but I will explain. Okay, so originally I put here 60,000 shim and then I mark the nut. So when I assemble that, this pin here that is for 90-degree pin, it didn't sit on the top of it. It was small gap here. It didn't work that way. So what I did, I removed the shim, but then the nut didn't fit anymore. That was originally. So this is original nut here, and you can see it's offset. Even I machined those gaps here on the top side. It's still, this screw was very close to the top. When I put this bushing here, I had to make another nut. So I will show you this other nut. So this is the bushing that I made for this hole. Originally there was a small bushing that was flapping inside. So the second nut that I made it out of brass, so that it's a little bit easier to machine, because so you can see in comparison those two nuts. This first one, the hole was very close to the edge of the nut, and this one it's actually dropped down for 60,000. I installed the nut here, clamp it, and then using transfer punch I mark the hole where the nut needs to be tapped, and then I tap it. Okay, so now you can see that, you know, with this thing you can actually move this back and forth, you know, to adjust this piece. So I also replaced this with the lever type. Originally was some nut like that, and screw was coming from the back side. So it was very difficult to take it off and put it back together. Now this thing works much easier. Second thing that I didn't record, and this is adjustment for the parallelism of this side of the bed. So underneath there are two sliders that actually, when you rotate this wheel, it's moving the table up and down, but also it's moving it on the angle. So it actually moves like that, up and down. Okay, so I don't know if you can see it, how it actually goes. Of course, there is nothing here that show you dimensions, you know, how much you go up and down. I will just put some scale here and some clear windows with a line so that you can see what is your height, how much you actually dropping it down, and depth of the cut. Okay, so for the adjustment, I'll show you. I don't know if it's visible or not from underneath. Okay, you can see here there are actually adjustment screw. This is a bigger one, and a locking screw that lock again a position. This table has 4 adjustment screws. This is what make it a little bit difficult to align, but also allow you to slightly bend and deform the table if it's already deformed. So to make it parallel with this side. So originally this is how I did. I release all these screws, not completely take them out, just to release them, and then using some straight edge, adjust the height here and here. You know, on those 2 first nuts, you see the markings. Here is the 2 first adjustment screws here, and further down there is where the second one. When you do this adjustment, machine needs to stay like that. You cannot turn it on the side and do this adjustment because you need the weight of the table to be able to measure. I unscrew these locking screws, and then by hand tighten those adjustment screws first on this side, and at that time the table needs to be all the way up. Okay, and then using the longer straight edge, you adjust the back side. So when you're adjusting the back side, front side, drop a little bit down if this one was lower, or if it's higher, this one will actually go high. So you are doing back and forth, this 2 and this 2. First adjusting the height, and then you need to adjust in this direction, you know, using 2 front or 2 back screws. It's tedious job, but when it's done, you can make the table within 1,000 parallel with this part, as long as this is perfectly flat. So this is pretty much what is done on the table. Okay, so this is adjustment screws for to hold this in place. You tighten everything. So what I'm gonna do, I'm gonna cut a little bit of this 2x4. This 2x4 is kind of a warp. So I just actually going to show you that machine is operational. will be all. Thank you for watching.